It's dangerous. Yeah, where was I?
Progress
yeah,
bar.
Perception, progress bar. So the idea is that if you don't know how long something takes, what you definitely have to do is make sure that in less than 250 milliseconds, you have some kind of a spinning circle on the screen or some moving line such that the person looking at the interface can see that the program is doing something. If you can, you should give some intermediate results. For example, let's say we apply the black and white effect. It takes some time to convert the picture to grayscale or just plain black and white. You could, let's do it like this. It's a timeline. This is where I begin my action, and this is where we have a 100% result. You could have this. As soon as I click this button, do nothing, work for, let's say it takes 5 seconds, and then when it's done, show them the result. You could also do something else. In less than 250 milliseconds, draw a little spinning circle, and then when it's done, show the picture. Or you could begin rendering it line by line or column by column, depending on how your algorithm works. This way, as a human, I can see that yes, the program is working right now. I can also see whether it's halfway through or 80% done. In other words, I see an intermediate result, and I see how much there is left until the process is complete. And in another experiment, a group of people did this. They had, let's say you have a program that does some sort of a calculation. Program A does this calculation in 5 minutes. Program B does it in 8 minutes. So this one is more efficient. In terms of programming, they used super low-level assembly code, high-tech data structures, and whatever they could, latest, greatest stuff, they did it. These guys were a little bit lazier. They didn't invest that much time into optimizing their algorithm, but they both produced the same result. Now, the only difference is that this program, which takes less time, it works like I showed you here in the very beginning. You press a button, nothing happens, and after 5 minutes, you get your result. This one, you press a button, you have a progress bar, and after 8 minutes, you get a result. If you ask people which one was faster, they will tell you that this one was faster, even though we know that's not correct. But what matters is perception. Now, keeping that in mind, you must always think about a nice way of visualizing the progress of your long calculation. You must always ensure that you have some kind of feedback in less than 250 milliseconds. Otherwise, people will perceive the program as slow, and that's a bad thing.
Or it's not working.
Or it's not working.
Yeah, it's like you try to run a ping to a server without any, kind
Which is why, for example, when Windows loads, you have this little blue line. Windows 95 had it, 98, well, all of them had it. Not as of Vista and above. I don't remember that one. But yeah, that's why the blue line is there. When it's moving, you know that the computer is doing something for you.
Yeah.
When it's not moving, something is obviously wrong.
Which is kind of weird, but Apple, I don't think Apple has that. So you just turn it on.
No, but it goes
It
down.
has a circle.
Oh yeah, that's a circle that is rolling. Yeah, you're right. Yeah, it doesn't have the bar.
So those things are there not just to make it pretty. They're there to indicate status
Perception.
and to make people more comfortable.
Windows
And
7 and something.
while we're at it, and I mentioned Donald Norman, he has a very cool publication called, well, it's a PDF you can download from his site. It's called The Psychology of Waiting Lines.
Mhm.
Where he discusses perception and a person's subjective impression of how fast a queue moves when they wait in line. He also provides a very nice set of recommendations. What you should do to make sure that your queue moves fast, that people can't cut the queue, and that you don't wait longer than you have to. Now, imagine that you have a store with multiple lines. And when you've done your shopping, you have to pay for your stuff, and you have to choose one of the 5 lines. According to Murphy's law, you always choose the slowest moving line, or one which appears to be short, but when you get to it, all the other ones suddenly, and only when you make a switch, this one is empty and then you go back. So it's a psychological trauma when you have to go through this. And this is not good for perception, because you go to that store and you feel like you've been humiliated by all these people around you, the sellers, the other customers, because they somehow chose the shortest and fastest line, and you ended up with the slowest one. So he provides some practical recommendations, such as you should have just one line, and you could make it go spiral, but you have to have multiple servers. Let's say in this case we have 5 cash registers. So everybody is in the same line, and whenever any of these is ready, you just go here, then here. Whereas what people do, I mean, at least in my country, what they most often do is they just have 5 different queues. And if you place your bet on the wrong queue, then you just have to stay there because you've made your choice. But this one completely eliminates the need of making a choice. It also moves fast because it is served by 5 servers, not just one. And you don't have this feeling that you made the wrong choice, that you chose the
But this
slowest
could be
one.
debated, right? If you have 5 lines, right, then you think the average waiting time is like, 5 people or 1 person, like who's waiting in that queue, right?
Mhm.
And if they get together, like there are 25 people, so you're 26th person, right?
But
Mhm.
Then there's a mental block associated.
but that is, you're talking about technicality. This is about perception.
That's I'm talking about just the perception,
Okay,
not the
yeah, I have
technicality at all.
an argument for
This
that.
is not a technicality, this is perception. If I see 25 people standing in front of me, will I get more intimidated by that? Or if I just see 4 people
Yeah.
standing, 5 people standing
So,
in front of me?
which is why this queue is spiraled such that you are physically closer to the server. Of course, you could make it just one long line, but then you would be here, and the person would be there, and it would be really far away. So this does give you this long distance perception. So you compress it by spiraling it, that's one. And second, it turns out that what matters is the speed at which the queue moves, not the number of people in front of you. In the case of 5 separate queues, you have to make a choice, and once you've made that choice, you just commit to it, and that's it. But in this case, you know that this is the only option, and you are sure that the queue moves as fast as it can. And as the study revealed, speed matters more than the number of people in front of you. So without having this empirically collected data, it would be a difficult decision. But now that we know what actually matters and what people react to mostly, then we can make our choices accordingly. Do you have other comments about this? Okay, then let's take a short break, and then I will switch to examples from the world of computer security, and then maybe we'll connect the projector and I'll show you a few examples because they require stuff, drawings. I can't replicate them on the whiteboard.
Mm-hmm.
So let's have a 5 to 10 minute break.
I gotta go, but I'll watch the rest.
Yeah, I'll upload them tonight.
Okay.